Let's take a look at the molecular geometry and bond angles for AsO4 3-. This is the arsenate ion. So we'll start out with a valid Lewis structure. And this is our Lewis structure, and we have these brackets here, 3- because it's an ion. So when we look at the Lewis structure here, we want to look at the steric number. How many things are attached to our central As? We have 1, 2, 3, 4 things attached. And we don't have any lone pairs. All of these electrons here, they're involved in chemical bonds with the oxygens. 0 lone pairs. Tetrahedral, our bond angle, 109.5. Let's take a look at that and visualize it in 3 dimensions. So the purple, that'll be our central arsenic atom. We're going to add 4 oxygen atoms. 1, 2, 3. These have single bonds. Right now we have a trigonal planar molecular geometry. We add the last oxygen atom on there, and we can see we end up with a tetrahedral molecular geometry. Bond angles would be 109.5. If we wanted to look at the electron geometry, since there aren't any lone pairs, all the bonds here are between atoms here, the electron geometry, that would also be tetrahedral for this AsO4 3- ion. Let's go back to our Lewis structure. We could also figure out the molecular geometry for AsO4 3-, the arsenate ion here, using the AXE notation. So A, that's the central atom, that's the arsenic, and then X, that would be the number of atoms attached. We have 1, 2, 3, 4, and E, that would be the lone pairs. Sometimes you'll see AXE 0, sometimes just AX4. If we look up AX4, we'll find it's tetrahedral, bond angles 109.5 degrees. This is Dr. B with the molecular geometry and bond angles for AsO4 3-. Thanks for watching.